Hello students, in this video we are going to discuss 4.11 and 4.12 from laws of motion. A truck starts from rest and accelerates uniformly at 2 meters per second square. At t is equal 10 seconds, a stone is dropped by a person standing on the top of the truck 6 meters high from the ground. What are the velocity and acceleration of the stone at t is equal to 11 seconds? Neglect air resistance. Here, if you observe clearly, the truck is accelerating with 2 meters per second square. At t is equal to 10 seconds, the stone is dropped. So we can take the situation like this. So this is the truck. Assume that, and it is moving in this direction with an acceleration 2 meters per second square. And here is a man standing from the ground. A man is standing in the truck and the height is 6 meters from the ground. That means he has dropped a stone from here. So with respect to the ground, the height is 6 meters. Now what will happen? So generally from this point, from the ground, the point or the stone is at a height of 6 meters, and if it is dropped means it will travel like this parabolic path. It will travel like parabolic path. That means initially it is having horizontal velocity and there is no vertical velocity at time t is equal to 10 seconds. Now, during the first 10 seconds, the horizontal component of the velocity Vx can be taken as u plus at 0 plus 2 into 10, that is nothing but 20 meters per second. And at this case, Vy is equal to 0. At t is equal 10 seconds, Vy is equal 0. But the question asked is, a stone is dropped by a person standing on the top of the truck at t is equal to 11 seconds is mentioned. At t is equal to 11 seconds means somewhere the particle is here. Then what is the time interval between these two means 1 second. Therefore, the vertical component of velocity, what you can take from 10 seconds to 11 seconds, that is equal to u plus gt, that is 0 plus 10 into 1, that is 10 meters per second. So at this point, vertically downwards, the velocity is 10 meters per second and the horizontal velocity will be remain same, either at t is equal to 10 seconds or at t is equal to 11 seconds. Therefore, the resultant velocity from the question number A, resultant velocity, we can take V is equal to Vx square plus Vy square under root. That is equal to 20 square plus 10 square under root. After simplification, we will get it is 10 root 5. That is also nothing but is equal to 22.4 meters per second. So this is the magnitude of the velocity. While coming to the direction, tan theta. So this is with a horizontal. With a horizontal, tan theta is equal to Vy divided by Vx. That is 10 by 20, nothing but 1 by 2. From this, tan theta is equal to half means theta is equal to tan inverse of 1 by 2. That is also nothing but 26.7 degrees with horizontal. While coming to B, acceleration of the stone at t is equal to 11 seconds. Here, acceleration along x-axis is 0, but the only acceleration is vertically downwards. We can write acceleration is vertically downwards. How much value that is? Nothing but that is g is equal to 10 meter per second square. So therefore, net acceleration will be downwards slope. Coming to 4.12, a bob of mass 0.1 kilogram hung from the ceiling of a room by a string 2 meter long is set into oscillation. The speed of the bob at its mean position is 1 meter per second. What is the trajectory of the bob? The string is cut when the bob is at one of its extreme positions and at its mean position. The situation you can take like this. A bob is suspended and the length of the string is nothing but 2 meter. Whenever it is undergoes the oscillation, then we will have, suppose I am naming it is O, A and B. A and B are nothing but called extreme position and O is nothing but called mean position. The first sub-question is at one of its extreme positions onwards the bob is released. The string is cut when the bob is at one of its extreme position. Assume that the bob is at point A at extreme position. The string is cut. Then what will happen here? The speed of the bob is 0. Then what will happen? It will be acting as like freely falling body and the bob will fall down like this. It is acting as like freely falling body. So I will write the speed at this case is 0. That means the bob is momentarily at rest. The string is cut and the bob will fall vertically downwards. Coming to B. At its mean position. At its mean position, the bob has certain velocity. The speed of the bob at its mean position is 1 meter per second. Suppose say here u is 1 meter per second. Now whenever it is cut, the string is cut. So it has look like horizontal velocity with 1 meter per second. After that, because of the gravitational force, it will change its path like this and travels in parabolic path. So at the mean position, the bob has horizontal velocity, that is nothing but suppose say ux is equal to 1 meter per second. The string is cut, it will fall, that means the ball will fall along a parabolic path under the effect of gravity. So these are the solutions of 4.11 and 4.12.